So I'm going to do a couple homework problems in this video. Number 2 looks really similar to a problem that I did in the other video. Number 6 says to use a calculator, so go ahead and graph that in your calculator and just kind of sketch what it looks like. Swing to pi, oops, it's a calculator. This one, number 8, they call it the rows. It says to plot 6 points. Okay, so if you have to plot 6 points, I'd probably pick radians that you know, like 0, maybe pi over 2, maybe pi over 4, 3 pi over 4. Let's do pi, and maybe 5 pi over 4. You can pick whatever points you want. I'm just picking points that I think are easy, especially because I see that 4 theta. So the 4s are going to cancel. So I'm cheating a little bit. Let's start putting some of these in. So 4 times 0 is 0. Cosine of 0 is 1. So I get 3 times 1, which is 3. Now, this is actually backward. The theta is first and the r is second. It really should be 3 comma 0, meaning 0 radians. So you swing, you extend out 3, and you don't swing it because the radian is 0. Okay, so let's do 4 times pi over 2, which would be, what would that be? That would be 2 pi. Cosine of 2 pi, again, is at 1. So at pi over 2, we're at 3 again. So I'm going to graph 3, comma, pi over 2. So that's going to be, you extend out 3 and you swing to pi over 2. If I were to show that, I could maybe show that this way, which would give you this point. Okay, now let's do pi over 4 times 4, which is just pi. Cosine of pi is -1, so I get -3. So if I were to swing out 1, 2, I'll do it in green. 2, 3, there's -3. Again, I should rewrite our polar coordinate is -3 pi over 4. So you go -3 out, and then you're going to swing pi over 4 in this direction is going to land me right here. Okay, let me erase some of my markings so we don't get them confused. Okay, and then, oh, I have 2 pi over 4s. Let's change this to, oh, that's 3 pi over 4. Okay, so 4 times 3 pi over 4 is 3 pi, cosine of 3 pi. So I go around the unit circle once and I end up at, it's the equivalent to pi, which would be a negative again. So I'd get -3. So I'm going to go -3 again. And then swing 3 pi over 4 would land me here. So I graph that point. 4 pi, when I plug in pi, I get 4 pi. That's 2 rotations around the circle, but I still end up at 0. Cosine of 0 is 1. 3 times 1 is 3. So at +3, there we go. At +3, I'm going to swing to pi, so I end up at this point here. And last one we'll do, 4 times 5 pi over 4 is 5 pi. 5 pi is coterminal with pi, where cosine is -1, so you get -3. So I do the -3 and swing to 5 pi over 4, which is going to land me here. Okay, if you actually graph this, it's called the rows. Once you do all of the radians that exist in the universe, and it's kind of neat on a graphing calculator. I don't think it does it on Desmos, but you can actually see it and graph it. So would I require you to be able to come up with that shape? No, but you do have to be able to find 6 points on the graph. Okay, so this is our first question. It shows up in the homework, not in the notes, to figure out intersections. So I went ahead and graphed the 2. R equals 2 is a circle with a radius of 2. And then we've got a cardioid, 1 minus 2 sine theta, and you don't have to know the name. But I want to know where the intersection points are. They have to be this guy right here and this one right here. How do you find those? So you do it just as you would any equation. You set the two equations equal to each other. So if r equals 2, that means 2 equals 1 minus 2 sine theta. Let's back down on this pen. Okay. All right. So I'm going to subtract 1 and divide by negative 2. And look at that. Where is sine theta equal to negative half? It's equal to negative half in two places. It's equal to negative half in 3 and 4, right? So sine pi over 7 pi over 6 and 11 pi over 6. So if I had to tell you where these 2 points are of intersection, this point is radius 2 theta 7 pi over 6. And this point here is radius 2 theta 11 pi over 6. So to find a point of intersection, set equal, solve, and then write coordinates. Okay, so that concludes today. I recommend that you Google cool polar graphs to graph. There's some really neat ones out there. If we were together, we would kind of play around with them. So if you have a second, you should Google them. It's kind of fun, the things that you can graph in your graphing calculator. Other than that, we have a formative coming up. I'm writing it right now. And being able to graph some points of a polar graph and solve will be on that formative. You guys have a lovely day. Can't believe it. One day left. Bye.